This is Mr. Mathis. In this video, we're going to look at gravitational potential energy. We'll review what energy is, explain what makes energy into gravitational potential energy, and we'll talk about energy conversion. Remember that energy is the ability of something to do work or cause change. Energy is measured in a unit called joules, and it comes in many forms. It can be nuclear or kinetic, it can be heat energy or elastic, it can be chemical energy in food, or many other kinds of energy. Gravitational potential energy is energy that happens because an object is near another massive object and there's a gravitational force pulling them together. Usually when we talk about gravitational potential energy, the other object is Earth. You can think of how an object that's high above the ground has energy that's pulling it down. That's gravitational potential energy. Gravitational potential energy depends on two things. It depends on an object's mass, and it depends on the object's height above the ground or above another reference surface. The equation for gravitational potential energy is PE equals mgh. PE is our potential energy, and the unit is joules. M is for mass with a unit of kilograms. Little g is the acceleration due to gravity near Earth, which is always 9.8 meters per second squared. And h is the height in meters above the ground or above the other reference point. Let's use the Q system to solve an example problem using gravitational potential energy. Sarah uses a forklift to raise a 42 kilogram box to a height of 2.8 meters above the ground. How many joules of potential energy did Sarah give the box? From the problem, we know that the mass is 42 kilograms and that the height is 2.8 meters. Our unknown is potential energy, and we're going to use the equation PE equals mgh to find the gravitational potential energy. Substituting the knowns into the problem, we have potential energy equals 42 kilograms times 9.8 meters per second squared times 2.8 meters. Remember, little g, 9.8 meters per second squared is always the same. Multiplying the three numbers together, we see that potential energy is 1,152.48 kilogram meters squared per second squared. But remember that unit is the same thing as a joule, so our potential energy is 1,152.48 joules. Energy doesn't always stay in one form. It can be converted back and forth between different forms, even though the total amount of energy stays the same. For example, if you rolled a big ball down a hill, the potential energy it had from being on top of the hill would turn into kinetic energy as the ball rolled down the hill. The amount of kinetic energy that the ball gained would be equal to the amount of potential energy the ball lost. This is called conservation of energy. In this video, we've reviewed how energy is the ability to do work or cause change. We saw that gravitational potential energy is due to the position of an object above another massive object like Earth, and that gravitational potential energy depends on the mass and the height of the object using the equation PE equals mgh. We learned that energy can convert between kinetic and potential energy, and that the change in potential energy is equal to the change in kinetic energy, and that the total amount of energy in the system is conserved.